So let's talk about AI, but not just using it. What if we could build our own framework from the ground up? I mean, really tear it open, see how it works, and make it something anyone can understand. We're diving into a proposal that aims to do just that, and it kicks off with a really sharp question about the very tools we rely on.
And here it is. This question it's really the heart of the whole thing, isn't it? It gets you thinking. The tools we use every single day, are they actually empowering us? Or are they just getting in the way, hiding the stuff we really need to know to innovate? That's the big problem, the central conflict that this whole NovaCore idea is trying to solve.
Right? And that tension, it leads straight into what this proposal calls AI's complexity crisis. And look, this isn't about the theory of AI being hard. We know that. This is about something else. It's about the tools themselves becoming the problem, the actual barrier that stops people from learning and getting involved. They call it the walled garden effect, and that analogy is just perfect. Think about it. You get to walk through this amazing, beautiful garden, but you can't touch the soil, you can't see the seeds, you have no idea how any of it actually grows. That's what it feels like using some of today's AI frameworks. Yeah, they're super powerful, but they're also completely sealed off. And why does that matter? Well, because it means only a handful of people hold all the knowledge, it makes it way harder for new people to get into the field, and you know what? It actually slows down real, game-changing innovation. And this really hits the nail on the head. The second a tool becomes a black box, a total mystery, everything changes. We stop being creators, the people who can actually build new things and push boundaries. Instead, we just become users. We're just pressing buttons, following instructions, without really getting what's happening under the hood. Okay, so how do we actually tear down those walls? Well, that's where the vision for NovaCore comes in. It's not just another framework. It's a direct answer to this whole complexity problem. The goal is to build something totally different from the ground up.
And here's the mission, right here. I love how specific this is. Modular, that means you can pull pieces out, swap new ones in, like Legos. Developer-friendly. Obviously, it shouldn't feel like a chore to use it. But for me, the magic word is hackable. That's the real game changer. It's practically begging you to take it apart, to mess with it, to really truly understand how it ticks.
So what makes NovaCore different from everything else out there? It really comes down to these four big ideas. First, it's all about education. The documentation is designed so you're learning while you're coding. Second, that modular design we talked about for maximum flexibility. Third, it's got to be fast. High performance is non-negotiable. And last, but honestly most important, full transparency. This is the direct assault on that black box problem. No secrets, no magic happening behind the curtain.
Okay, that all sounds fantastic on paper, right? But what does it actually look like? How does it work? Let's get into the nitty-gritty, the actual blueprint, and see how this vision turns into code. All right, the whole thing is built on three main pillars. First up is the NovaCore Tensor Library. If you're new to this, just think of a tensor as a super-powered container for your numbers. It's the absolute bedrock of the whole system, the engine that crunches all the numbers. Next, you've got the Model Zoo. This is exactly what it sounds like, a collection of pre-trained models. Think of them as starter brains that you can grab and fine-tune. And finally, there's the training framework. This is the part that actually runs the experiments and, well, teaches the models.
But if you zoom in right to the very core of NovaCore, you find this one thing, the Nova Tensor. This is the fundamental building block. It's not just a box for numbers, it's a smart box. It holds the data, sure, but it also remembers every single step of its journey. And crucially, it tracks something called gradients. And what's a gradient? It's basically a little hint, a clue that tells the AI, hey, to get smarter, you need to adjust yourself in this direction. It is literally the secret to how these things learn.
And that ability to track gradients leads us to the real magic trick here, AutoGrad. It stands for automatic differentiation. Basically, every single time you do anything, like add two numbers together, the framework takes a note of it. It builds this incredible, detailed map of every calculation. Then, when it's time to learn from a mistake, it just walks backwards along that map. It's like a detective retracing the steps of a crime to figure out who's responsible. That process is how the AI figures out exactly what to change to get better next time. It's brilliant.
So we've got the vision, we've got the architecture, but a great idea is nothing without a plan to make it happen. Let's take a look at the actual roadmap for building this thing.
The roadmap is ambitious, for sure, but it's also super clear and broken down into a 6-month plan. For the first couple of months, it's all about building the core, the tensor library, the AutoGrad system, all the foundational stuff. Then, months 3 and 4, you start building some heavy-hitting models on top of that foundation, like a vision transformer. And finally, months 5 and 6 are about growing the ecosystem. That means great documentation, tutorials, a model hub, all the stuff that makes it truly useful and educational for the community.
And what's the first major milestone? The first thing they need to get working? A simple MST classifier. Now, if you're not in the weeds with this stuff, MNST is the classic hello world of machine learning. It's a program that learns to recognize handwritten numbers. It might sound simple, but getting this to work is a huge deal. It proves that all the fundamental pieces, the tensors, the AutoGrad, everything, are all working together exactly as they should. It's the first sign that this thing is alive.
So, as we start to wrap up, it's pretty clear this is about more than just writing code, right? This is about starting a movement. It's about building a community around a totally different way of thinking about AI. It's really a mission to pry open those black boxes and make this technology understandable for everyone.
And to make that mission a reality, they're making some really smart choices about the foundation. Of course, it's going to live on GitHub, the heart of open source. The license is MIT, which is super permissive, basically telling everyone, please take this and run with it. And the technology? It's all built with Python and other standard tools, so there's no weird learning curve. It's designed for the AI community to feel right at home.
And that really brings us back to where we started. This whole proposal, NovaCore, it's not just about a new piece of software. It's about a whole new philosophy. And it leaves us with this huge, important question to chew on. Just imagine for a second, what could we build? What could you create if AI wasn't a locked black box, but was instead an open book for every single one of us to read?